All right, so now that we know what a compound is, we know how to calculate things like molar mass, we can use the formula to be able to calculate what the mass percent of any of the elements would be. It's going to take a couple steps, but it's not going to be a super complicated type problem. First thing that we're going to have to do is we're going to have to be able to calculate what the molar mass would be. So we're looking at the formula of aspirin, C9H8O4, and we are going to calculate the molar mass. This is not a terribly difficult thing to do. You're going to do it literally hundreds of times throughout this semester, so it's good to get a foundation for how to do it. I like to write everything out, so I'm going to take care of the carbon and the hydrogen and the oxygen individually, and then add all of them up. So I've got 9 carbon atoms. I'm going to take 9 times the molar mass, or the atomic mass of carbon. And remember, we always want to take at least 2 digits. So for carbon, it's 12.01. And for hydrogen, we've got 8 hydrogens. Each one is 1.01, or the atomic mass of hydrogen is 1.01. Then we got 4 oxygens, 4 times 16.00. Again, notice I've taken at least 2 decimal places for everything. Why? Because when we add these up, then we're going to be significant the whole way to the 100th place of our resulting answer. And so you multiply those, add them all together, and you should end up with 180.17 to 2 decimal places. That's the number of grams in 1 mole of aspirin. So now what we want to do is we want to be able to calculate what the mass percent of carbon is in that compound. Well, we know how many grams are in 1 mole, so what we're going to do is we're going to assume that we have 1 mole of aspirin. Okay. Now this is a percent problem, so we are going to be calculating a percent. All right, percent, remember the percent, any percent, but in this case percent mass is part over the whole. The part is going to be the mass of carbon, and the whole is going to be the mass of aspirin. Part over the whole times 100%. Because we are calculating the mass percent of carbon in the aspirin. The part would be the mass of the carbon, and the whole would be the mass of the aspirin. And these are all going to play out this way in a very similar fashion. Now, how do we calculate this? Well, first we're going to take the straightforward part. That's the mass of the aspirin. When we assume that we have 1 mole of aspirin, it means that we have 180.17 grams. So my denominator is 180.17 grams of aspirin. The top is going to be how many grams of carbon do we have. We're going to have to come back and we're going to have to take a look at what we've done to figure out the molar mass. Because remember, we've got 9 carbon atoms, and it's 12.01 grams per mole. So we can figure out the mass of carbon by taking the 9 carbons times the 12.01 grams per mole. The portion of that molecule that's carbon goes on the top. Multiply that by 100%. And when you calculate that through, you should end up with a percentage of 59.99%. Okay, 4 significant figures. And it tells us that whenever we look at aspirin, the most mass or the majority of the mass of aspirin comes from the carbon atoms that are inside that particular molecule, or that particular aspirin molecule. So about 60% of that mass is due to the carbon atoms. Hydrogen is a very light element. It's not going to contribute much mass at all. So that number would be much lower. And I would guess that for the most part the bulk would be oxygen. So somewhere around 35 to 40% would be oxygen, and then the hydrogen would be somewhere in the single digits. So looking at it and trying to determine, roughly does it make sense? Well, we have a lot of carbon atoms. Okay, it has a fairly decent mass, decently sized mass of 12.01, and we have 4 oxygen atoms. So it does kind of make sense that the bulk would be carbon, next would be oxygen and hydrogen. And we could calculate hydrogen or calculate oxygen in the same way that we did it here, except instead of mass of carbon, it would be mass of hydrogen or mass of oxygen. So you can ask for anything that's within the formula of that compound. As calculating the mass of a particular element in a compound, and it's pretty straightforward, and they all work in pretty much the same way.